Hello, today's lesson is on 3.4 and it's all about the distributive property. You've probably used the distributive property to do mental math to multiply two numbers, and particularly if it's two double-digit numbers. And so I'm trying to get you to think about, what does the word distribute mean? So hopefully you're thinking that it kind of means, like, for instance, I'm thinking about a mailman, right? A mailman distributes mail. Mailman distributes mail. And so basically what he's doing is he's handing out, right? Some people think about it as divide out. And it's not necessarily that you're dividing something into equal groups, but the idea is when you are handing out an item, you are distributing it. In Mrs. Clifner's class, I have paper dispensers. That's one of my student jobs, right? And so paper dispensers, they hand out the notes each day that we use in class. And so that's what I want you to think about when we're distributing. We're handing something out. Okay, so I'm going to show you something that kind of uses the distributive property in a way that you've seen before, right? I'm pretty sure that in elementary school you started multiplying double-digit numbers with the area model. And so I'm going to move this bar over so that you can see our Farmer Fred there. There he is. Okay, so Farmer Fred has a big pen, and he's trying to put two different animals in the pen, and he wants to separate them. And so the first thing I want you to think about is you can find the area of the pen, right? Because it's a rectangle. And the area of a rectangle is, length times width. And so this is the length, right? Length I usually think of as the long edge, and the width is kind of the height here. But I'm going to call this length and this width. And then if I count the width, 1, 2, 3, 4, 5, 6, I'm going to put a 6 here, because this is 6 units. I don't know if it's feet or yards, but it doesn't really matter for this example. And then if I count the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, this is 11 squares in length. So there's my 11. So when I do 11 times 6, it equals 66. And that's how you guys first started multiplying, right? 6 groups of 11 or 11 groups of 6 equals 66. And I'm just going to write that it's 66 square units. The units could be feet or yards. And now the idea is, if I'm going to separate the pens, right, then I take some kind of a fence and I put the fence in between the turkey and the chicken. And so let's say I put the fence right there, and now I count 1, 2, 3, 4, 5. So this part of the fence is 5, which means this side has to be 6, because I know altogether it equals 11, and I count it 1, 2, 3, 4, 5, 6. 5 plus 6 is 11. And so when I count the area of just the turkey's pen, it is 6 times 5. And the chicken is now 6 times 6. And I know that 6 times 5 is 30, and 6 times 6 is 36. And yes, 36 plus 30 adds up to 66, which is what we knew it was. But I'm basically looking at distributing the 6 to the 5 and the 6 over here. Now I could go ahead and erase all that, and I could try another position. Let's say we only give the chicken 4 units, right? So that makes this part 7 units, and then I have 4 units here, and I know that the width is still 6. So the area of this portion becomes 6 times 7. The area of this portion is 6 times 4. Now what I want you to look at is, think about, this is the sum of, so it's the sum of 7 plus 4 times 6. And here's how I write that. The sum of times 6. And this is how you are going to see distribution problems in your classwork today. And so this is the area model that you've seen before. And the area of this pen was 42, and the area of this pen was 24. And if I add those together, I get back to the 66, which is the area of the whole thing. And so let's keep going to the next example. So now what if the farmer has 3 birds that it's trying to separate out. I'm going to count 1, 2, 3, 4, 5, 6, 7. Okay, so now the width is 7. And when I count along the length, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 7 times 14. So if I do the math to figure out the area of the whole pen, I get 98. So the pen is 98 square units. Okay, so now I'm going to put in 2 fences and see what happens to my expression for the area. If I put in 1 pen here, that's 4. I can do this. I can give this chicken 4 and give the duck more room. So this becomes a length of 4 plus 4. So hopefully this is 6. If I did my math right, 1, 2, 3, 4, 5, 6. Okay, so this is plus 6. So now the whole length is 4 plus 4 plus 6, which we know is equal to 14. But each of the 3 separate areas is 7. So this area is 7 times 4. This area is 7 times 4. And this area is 7 times 6. So what I've done is I've created a mathematical expression that gives me the area of the 3 pens. And I know it's that it really, the expression is 7 times 4 plus 4 plus 6. I would multiply the 7 times 4, the 7 times 4, and the 7 times 6. Okay, now let's look at some examples. And you did this in elementary school. That's my note on the side. I'm going to move this over. Okay, so, and I'll just take that. I don't need that. Okay, so yeah, you did this in elementary school, but the idea is it kind of makes sense that when you are learning how to multiply a double-digit number, you can think about it as area. Over there. Okay, so the area of this square is 8 times 53. So I have 8 and I have 53, but I want to take the 53 and I want to break it up. And it makes sense to break it up like this as 50 plus 3, right? Because this is 5 groups of 10 and there's my 3. So the area of this rectangle is length times width, but I'm always going to do the width first because I'm trying to show you distributive property. So it's 8 times 50, and then the area of this skinny rectangle is 8 times 3. So my equation is 8 times 53 can be thought of as 8 times 50 plus 8 times 3, right? And we can all do mental math with the 8 times 50. If you know your times tables, 8 times 5 is 40. Then I have another 0, so it's 400 plus 24, which equals 424. Now, your teacher might have asked you to come up with some other interesting ways to break up 53. And so maybe you put the 8 there, but maybe this time you thought, well, maybe I'll make, let me undo that. Let's grab the line and let's make a line segment. Okay, let's say I did this and I've got 10, not big enough, plus 10, plus 10, plus 10, that's 40, right? 10, 20, 30, 40, plus another 10 is 50. Oh, I didn't do my spacing very well. Let's pretend it's spaced evenly. And this is 10 plus 10 plus 10 plus 10 plus 10 plus this is supposed to be a 3, so that didn't work out very well. But you can see what I did was I broke up the 53 into little parts of 10 plus 10 plus 10. And so the area in each side, each of these is 8 times 10. And maybe this isn't the best way to do mental math, right? I realize maybe for 3rd graders, this got even maybe a little bit harder because now you have to add 80 plus 80 plus 80. But the idea is in this picture, 8 times 53 is the same as 8 times 10 plus 10. Oops, I don't want to do that. I wanted to actually show the distributing. 8 times 10 plus 8 times 10 plus 8 times 10. Okay, yeah, I don't think this would be very easy for the 3rd graders. 1, 2, 3, 4. I need to have a 5th group of 8 times 10 plus the last one is 8 times 3. Phew, I think that made it more complicated. So it makes sense when you're doing double-digit numbers to separate the tens and the ones. All right, let's look at another example. So now I've got 6 times 99. So I'm going to argue that the easiest way to do that is just to take the 99 and say that it's 90 plus 9. So inside the area for this rectangle, we have 6 times 90. Inside of this rectangle, we have 6 times 9. So my equation is 6 times 99 equals 6 times 90 plus 6 times 9. And then, of course, we can do the math and get 540 plus 54, and that equals 594. Okay, so it's definitely easier when you break it up into tens and ones. Then I was thinking, I wonder if we think about take away. And what if we think about 99 is just 1 away from 100. So what if we did this? What if we called this, this is 6. Now I want to have 99 as my length, but what if I do 100 and then instead of adding, I'm going to take away this section. Ooh, that's interesting. So now I have 6 times 100 take away, so this becomes minus a 6 times 1. So my equation becomes 6 times 99 is equal to 6 times 100 minus 6 times 1. That's how you could do mental math in your head, right? So I could do the 600 minus 6 equals, 594. Hey, that's kind of a cool way. Next. All right, so now the farmer has the idea where he wants to make a pen, right? And he knows that the chicken's going to be 6 feet, and he's trying to figure out the turkeys, right? He might add some more turkeys. So what is an expression for the area? Knowing that instead of a number, it's now a variable, right? You're still thinking that the area is 9 times, but this time it's 9 times x, right? So the area of this square is 9 times x. The area of this square is 9 times 6. Okay, so this becomes 9x plus 54. So here's what you could tell the farmer, right? If he knows what the value of x is, he can plug it into this expression and tell you the area of the 2 pens. And then basically starts out looking like this. Remember how I told you that we could think about the length is being in parentheses, and it's 9 times the length. Okay, and this is the simplified expression that the farmer can use. Okay, so now we've got one that's really weird, right? It's all letters and no numbers, but the same thing happens if you're adding. The length is b plus c, and the width is a. So the area of this square is just a times b. The area of this square is a times c. So each area gets added together to find the total area of the rectangles that he has. All right. So now, this is what I want you to write in your math notebook. This is directly from your textbook. Notice it's a little mathy. It says to multiply a sum or difference by a number, multiply each number in the sum or difference by the number outside the parentheses, then evaluate. Okay, that's a whole lot. But if you watch the video that I said asks you to multiply the outside by the in. So you can just think of it as it's just multiplication, right? So you're multiplying the outside by the in because the number outside of the parentheses means to divide, and you have to distribute it to every single term. Remember how we talked about terms are being added or subtracted? The terms that are on the inside. So now I'm going to label this to match the numbers up above. I'm going to call this length 7, and I'm going to call this 2. So notice what I'm doing is when I find the area of this whole rectangle, it's 3 times 7 plus 3 times 2, which is what matches this example up here. Now for this box, I'm going to do a subtraction. So I'm going to say, what if for algebra I had b minus c? I'm going to take away. It equals So here's my A. Here's my piece of land that is B in length, and this is going to be taken away, so I'm calling it minus C. The area is A times B. This area gets taken away, but it's A times C. So A times B minus C is equivalent to AB minus AC. That is very abstract because there are no numbers. So the distributive property works for addition inside the parentheses as well as subtraction inside the parentheses. Okay, next, this is the OYO. So I want you to pause the video, try these on your own. You can label the box if you want with a P plus 7. I'm going to label this box. Let me move it over. And the 8 is on the left, and then this is, let's just call this M plus 4. Okay, I'm going to show you the equations, and you pause and try to do the math on your own. 3 times P, 3 times 7. So 3 times P plus 7 is equal to 3 times P plus 3 times 7. Now this is where I simplify. 3 dot P, get rid of the dot. A number next to a variable means multiply. Do the math. That's what I end up with as my simplified expression. Now I'm going to do this equation. Even though the 8's on the right side, I'm still distributing the 8 times everything. And it's better to have 8 as a coefficient. It's better to put the number first, the multiplier, and then the variable. So I'm going to do that in the same order. So here's my equation. M plus 4 times 8 is equivalent to 8 times M plus 8 times 4. That equals 8M plus 32. First two, easy, right? Okay, next. Now, again, this is just another example of where I've got something that can be taken away. I think about the area of this as 9 times x, and I'm taking this away, so I'm going to put a minus sign in front of it. So the expression becomes 9x minus 54. That is the area that you have left over for the pens. Okay, so here's some examples, and then we're going to do the last OYO. I'm just going to, instead of drawing the pictures now, I'm just going to show that I'm distributing, right? I'm multiplying the number on the outside to everything on the inside. That's what distributing means. So I'm going to rewrite this as 4 times n plus 4 times 5. Then I drop the dot and I just write 4n plus 20. Here's the second example. 12 times 2y minus 12 times 3. I want to do some associating. I'm going to put the 12 and the 2 in the parentheses because this is all multiplication, but I want to simplify as much as I can. 12 times 2 is 24 times y, and then I do the other math. 12 times 3 is 36. That is as simplified as I can get. The last example is 9 times 6. Oops, I'm going to do it up here. 9 times 6 plus 9 times x plus 9 times 2. I do the math with 9 times 6, I get 54. 9 times x is just 9x. 9 times 2 is 18. I'm going to use the commutative property, and I'm going to move 18 to the front so that I get 18 plus 54. Remember, I told you you want the numbers near each other. Now I can use the associative property and do this math first. I get 72 plus 9x. Most examples want you to list the variable terms first. 9x plus 72. It's not incorrect to list it that way. It just looks a little better if you list the variable term first. Okay, so pause this, try these. This is the last part of the video. You're going to try these on your own. Go ahead and pause it, and I'm going to do the math. I'm distributing the 7. Here I get 7 times a plus 7 times 2. 7 times a is just 7a. 7 times 2 is 14. I distribute 3 to everything in parentheses, but don't forget now there's a minus sign. So I get 3 times d. I'm taking away 3 times 11. 3d minus 33. Okay, last one. This is a little trickier because there's 3 multiplications to do. 7 times 2 plus 7 times 6 minus 7 times, I'm going to put the 4D in parentheses because there's more than one number or variable. And then I'm going to do the math with 7 times 2 is 14, 7 times 6 is 42, and then I have a minus. Now here's what I want to do. My first step is to regroup. I'm using the associative property. I'm going to put 7 times 4 in parentheses together times D. I don't want to do minus 7 first and then try to multiply because this whole thing is one multiplication. So that's why I rewrote it. Now I can do the math where I do 7 times 4 is 28 times D. Okay, so I'm getting there. Now I'm going to add the 14 and the 42 and I get 56 minus 28D. So I'm going to drop the dot in between and I'm just going to say 56 minus 28D. That's my final simplified expression. Now, if I put the variable term first, this is weird. It is a subtraction. So that subtraction has to stay with the minus 28D plus 56. If you're okay with turning it around and seeing something that starts out with a negative, that's awesome. You'll do that a lot next year. That's it for the lesson. Bye-bye.